Assalamualaikum to everyone. Today our group is going to talk about application of the first order of differential equation in electrical circuit. So, firstly, the introduction. Electric circuits are essential to modern technology, powering everything from home lighting to smartphones and computers. They consist of interconnected components through which electric current flows, enabling energy transfer for various tasks. Understanding circuit is vital for engineers, scientists and enthusiasts driving advancements in electronics, communication, renewable energy and more. Exploring concepts like voltage, current, resistance and component configuration reveals a world of innovation that shapes our daily interaction with technology.
So for the problem statement, let's say a scientist is conducting an experiment about resistor inductor RL circuit to control and measure current. When the switch is on at a certain time, the current will change its value. So that was the problem. The objective is to find the value of current and time it takes for the switch to turn on. That's why we are using the method of the first order differential equations, linear equations, which is dy over dx plus px times y equal to qx. These equations are important in mathematics, engineering, physics and many other fields because they describe various phenomena where the rate of change of a quantity depends linearly on the quantity itself, represented by y, possibly modified by external function pt and qt.
So to understand this method of linear equation better, here is an example of a question. So the question is as follows. A generator having an EMF of 100 volts is connected in series with a 40 ohm resistor and an inductor of 4 henries. If the switch is closed at time t equals to 0, set up a differential equation for the current and determine the current at time t. So, the answer to this question is as follows. We have to implement the linear equation into the question. And as we can see here, L di over dt plus IR equals to ET, which is actually just a KVL equation with a twist on the formula for inductor voltage. Because inductor is linearly changing its current over time, we have to use L di over dt in the formula. Then, we insert the information given by the question into the equation to solve it. So by the end of the solving, we will get di over dt plus 10i equals to 25. So now, the next step of the answer is to use the integrating factor or if to multiply it with the equation. So by the end of this calculation, we will get if equals to exponent 10t. Moving on, based on the equation, we can conclude that when time equals to 0, current will also equals to 0. So, we can find the value of C as shown in the answer. And as we can conclude, C will be equals to negative 2.5. And lastly, our general solution of current will be I equals to 2.5 minus 2.5 exponent to the power of negative 10t.
In conclusion, electric circuits such as resistor inductor, RL circuit that are solved using first order differential equation show that the current can change depends on its times changing. That's all for now. Thank you for listening to our presentation by Group 1.